Hello, everybody. In this video, we're going to talk about the very subtle differences between the linear, quadratic, and exponential functions. As always, before you start your work, add your name to these slides and share them with me as an editor. When you are done, you can submit the website link into Canvas. If you are on a Chromebook and you want to split screen so you can watch this video while you do the work, here are the controls to do that. You click Alt and this left bracket button. So let's get into this deck of slides. It's very short. The first thing we're going to look at are the definitions of these functions. And we have these three boxes that we're just going to click and drag into the right places. So first we have a linear function, and a linear function is any function whose graph is a straight line. And so the best way to think about that is linear has the word line in it. So we know that that one is a straight line. A quadratic function is a function whose independent variable is raised to the power of 2. And remember, our independent variable is the x variable. So in a quadratic, you will see x squared, x to the power of 2. And that leaves us with an exponential function is a function that has the independent variable as an exponent, meaning our inputs are an exponent. And we're going to look at this further. So a linear function, our input values, which are the x values, they're raised to a power of 1. And so we have an example here of a linear function and an example here of a linear function. Now, right here is our equation of a linear function, y equals m times x plus b. We know x is our independent variable, our input value, and we see that it is raised to a power of 1. In a quadratic function, our input values, which again are the x values, are raised to the power of 2. So if we look at this example here, this function is f of x equals x squared. So we take every input value and we square it. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and we get this shape that's called a parabola. So it looks like this. And here is more on a quadratic function. It has its own formula of ax squared plus bx plus c. We're going to learn about that later. But for now, you need to know that anything that is shaped like a parabola is a quadratic function. And finally, we have the exponential function. In an exponential function, our input values, which again are the x values, those values are the exponents. So if you look here first, we have our function y is equal to a times b to the x. And a and b are, well, a is a constant and b is what's called a base, but we're going to learn about that later. But our input value, which is the x, is actually in the exponent. So here is a good example of that. We have this function f is equal to 2 to the power of x. So every time we input an x value, we are doing 2 to the power of that value. And we see that exponential functions have these big curve ups, or they might even have these curve downs. So if you look at example C or example E, you see kind of like a flattening look on the curves. Or if you look at A, we have this curve getting bigger and bigger. On example D, we see the graph is going down. So an exponential function has this very slopey, curvy look to it. So on these next two slides, just try and practice identifying the types of functions that you see. Go ahead and click and drag the circle to tell me which function it is. There are 6 problems here, 2 examples of each type of function for these 6 problems. If you have any questions about these types of functions, please let me know. Thank you.